Hello everyone, this is DSA Zindabad. Today we are going to solve the 27th question of Arsh DSA sheet, and the question is largest rectangle in histogram. So now let's look at the problem statement. Given an array of integers heights representing the histogram's bar height, where the width of each bar is 1, you need to return the area of the largest rectangle in the histogram. So what is our main aim? Our aim is to return the area of the largest rectangle in the histogram. So now let's look at the example. Over there, we have this histogram, which is 2 1 5 6 2 3, right? Let me just paste this thing here also, right? So this is our uh, heights, right? Right. So from there, we just need to return the largest rectangle in the histogram. So over there, like this can be this can be considered as a rectangle. All these heights can be considered as a rectangle, right? So from this given array, we just need to return the largest rectangle in the histogram. Let's say this can be considered as a rectangle and its value will be equal to 2 into 1, which is ultimately equal to 2, right? 2 will be the area, right? And this can be extended to this and this, right? Let me just do this. This can be extended to this, right? So its length will be equal to 6, right? And the height will be equal to 1. So we just need to multiply. So we'll get 6, right? This can be one of the rectangle. And you can also consider this as the rectangle. Like this too can't be extended, right? There is a hole over there, right? So this is the first rectangle which we have of length like 1 and the height will be 2. So its area will be equal to 2 and this will be equal to 6, and this can also be considered as the rectangle over there, like this two, like this two, right? Because we can extend this to the like previous element, which is 6 and 5, right? So this is the rectangle. So ultimately its area will be equal to 3 into 2, which will be 6. So for all of these rectangles, we just need to return the largest rectangle in the histogram. The largest rectangle from there we can achieve is like this one, which is like this one. So ultimately, its area will be equal to 5 into 2, 10. So 10 is the, like, over there, you can also see the above is a histogram where width of each bar is 1. The largest rectangle is shown in the red area, which is this, right? Largest rectangle, right? Which has an area of 10 units. That's why its answer is 10 over there. So now let's jump into the approach and try to figure out how we can solve this question, right? So first of all, let's talk about the brute force approach, right? Let me just paste this thing over there also. So just look at the given array, like this is the heights, right? Heights. So over there, like just take this example, like this two. Can we extend the height of this to the right side? No, we can't extend. Just try to like analyze this. Like why we can't extend this? Because like 2 is greater than 1, right? Because 1 is smaller than 2, right? So that's why we can't extend its height over there, right? So now let's talk about this one. Can we extend its like height to 5? Yes, we can extend because 5 is smaller than that of the 1, right? So we can extend this. Can we extend its height to 6 also? Yes, we can. We can like extend until we found smaller element. Until we found smaller element. Smaller element, right? This is the main condition. all the question is revolving around this concept, like extension is until we found the smaller element, right? So now over there we can extend also over there because like 2 is greater than 1, right? Also from there. So we can also like we just need to consider all the direction, left and right, both the direction, because like ultimately this one can be extended to this two also. So ultimately its length will become 6 and the area will be equal to 6 into 1, which is 6 over there, right? So what's the concept over there? We just need to look in the both direction, like left and right, for each and every element, and we just need to analyze like to how much extent we can found the smaller element. Like let's say we consider this one, we can its height extend height until we found a smaller element. Let's say over there we have something like 0. So we can extend until this point and until this point. So we just need to maintain the boundary. Like for maintaining the boundary, we have left and right for each and every element, right? So this approach is like brute force approach, you can say. And how you can solve this, let me just write the pseudocode for the same. Like we'll have a for loop which will run from I till n, and here is the like size of the heights dot size, you can say, if this is vector, right? And we need to find out the left as well as right for each and every element, right? We need to find out these two things, and there will be a condition like over there, heights of left should be greater than equal to like heights of I, right? This is the condition. Then we just need to decrement our left pointer. Same goes for like right. Over there we'll have kind of right, same thing, and we just need to right plus plus, like same condition, same, right? And we just need to calculate the area by this formula, which is right minus left plus 1 into height. So so with this, like we can just do the coding, right? So now let's analyze the time complexity for this. Like for each and every element, we just need to find left and right. We just need to check this condition. So ultimately, this will require peak of n squared time complexity. The space complexity over there will be constant, as we no longer like require any extra space for this, right? So now let's try to think of some like better approach which do this the same thing in big of n, right? So now let's talk about the optimized approach, right? So in the this is a figure, right? So from this figure, like we just need to calculate left as well as right, these two things, and ultimately in optimized approach we just need to solve this using big of n time complexity, right? So to do this, like we kind of need some kind of data structure to store left and right for each and every element, right? We'll need data structure to store left and right. So for this, we'll be using list or vector or array, right? To store left smaller as well as right smaller for each and every element, right? Will be the left smaller and right smaller, right? So we'll directly declare two array where one named is left smaller and the another named is right smaller, right? So like this is a kind of for this also like we kind of need other data structure, which is stack, which will store indices of each and every element. So like, let's say if we have uh, something like this, increasing array, 1, 2, 3, 4, right? So there will be no problem. All the elements will be in the stack 1, 2, 3. So we kind of need like some sort of data structure so that we can compare each and every element in the stack. Like we just remember guys, like how we are calculating left and the right smaller. Like let's say for this one, we just need to check until which element it is extending, right? So we just need to check the boundary. You kind of need like boundary system over there. That's why we use stack to like make some sort of comparison. We can also like use some kind of like vector for doing the same thing, but like stack is much more convenient as compared to vector or array for doing so, like some sort of comparison, because ultimately we can directly compare the st dot top, right? We just compare the top element of the stack with the current element. Let's say over there we have 4. Let's take this example. Let's say some element is there in our stack, or the top element will be 6. Let's say 6. So now when we come to this 2, so this, the boundary of this 6 is ultimately this, right? Because it can't be extended neither to left nor to right. So its boundary will be this, right? So we just need to pop all this element, like let me just do a dry run, like so that this thing will be clear to all of you guys. Like it's a much more complex thing. I can say like why we are using stack. This will be clear to all of you guys. Like while I'll do the dry run for the same, right? So initially, let's first of all try to calculate the left smaller, right? Left smaller. So we'll declare a left smaller array of the same size, which is like over there. Let's say over there we also have some element 1, right? 0, 1, 2, 3, 4, 5, 6 of 7. 1, 2, 3, 4, 5, 6, 7, right? So initially we'll have a stack to store the indices. This is to store the indices, right? So now initially we are at this element, which is 2. So first of all, we'll check if there is any other element which is there in the stack. No, there is no other element which is there in the stack. So we'll directly push the index of that 2 into a stack, which will be 0, and it will directly be pointing to 2, right? So now we'll increment our pointer to 1. So like 1 is smaller than 2, right? So we'll directly pop this element out from the stack, and we'll directly, so it's like its boundary will be this, because it can't be extended towards right, right? Like so its smaller element, like left smaller, will be this boundary, right? This boundary, which is 0. That's why we write 0 over there, right? I hope this is clear to all of you guys, like why we are doing like 0, because there is no left smaller to the 2, right? So now when we move our pointer to 1, since 1 is smaller than 2, the condition for popping out the element, like when we found smaller element, then stack dot top, then we'll pop the element from the stack. So now at the top of the stack, we have 2. So we'll directly pop this out. right? So now our stack will be empty. Now we'll directly push one. So sorry, it's index over there, and we'll have one, right? So now we need to find the left smaller for this one. So we just need to find out to what extent we can extend its height towards the left, right? So now, as you can see, like over there, we have 2. Since 2 is greater than 1, so we can extend its length to 2. That's why we need to put 0, like 0 will be the left smaller for 1 for this one, right? So we can extend this. That's why its left smaller can is 0 over there, right? So now our pointer will move to 5. So now moving on to 5, like since 5 is greater than that of the 1, so we'll directly push 5 index into the stack, which is 2 over there, and we'll directly like store its index onto the like second index, which is 2, right? Like 1 plus like the st dot tops index plus 1, right? This is what we need to do. That's why 1 plus 1 will be equal to 2, right? So now after this, now as you can see, like our stack is increasing linearly. Remember guys, our stack will be increasing linearly. That's why we use stack over there rather than some sort of like you can say vector array, right? Our stack will be an increasing one. That's why we are checking this all of these condition, like when we need to pop the element from the stack, when we found a smaller element than the st dot top, right? Then we just need to remove the element. So in order to maintain the linear increment in the stack, right? So now moving on to 6. So like 6 can be, so we can't extend this 5, right? That's why we put 2 over there, right? So its boundary still remain in between this, right? Its smaller will be this. So now moving on to 6, like we'll directly push its index into the stack because it is greater than that of the like st dot top. So stack will remain like in the increasing order, right? Linearly increasing. So we'll directly push its index over there, which is 2 plus 1, like st dot tops index plus 1, which will be 2 plus 1 equal to 3, right? That's why we push like 3 over there in the left smaller array. So now moving on to 2. Now there comes the tricky part, right? Now understand this very clearly, like right, this step. So now when our pointer moves to 2, so 2 is smaller than 6, which is st dot top currently. That's why we need to pop this element from the stack. So we'll directly pop this element from the stack, right? So now again we'll check. So now again st dot top is much greater than that of the 2, right? So we'll again pop this thing from the stack, right? So now 2 is greater than that of the 1. So now we can push the 2 into our stack, push those index in, which is 4. So we'll directly push 4 into the stack. 4 indicates 2, right? So our stack remains in the increasing order, as you can see. So now what we need to do, 1, like remember guys, 1 plus 1, like st dot top here is 1 over there. So its index is 1, then 1 plus 1 equal to 2. That's why we have right 2 over there, right? I hope this thing is clear to all of you guys. Like if not, like once again rewatch this particular part of the video so as to get a better understanding, right? So now moving on to 3, pointer will pointer to 3, since 3 is written and then that of the 2, so we'll directly push its index over there in our stack. So now, right? So now it's 4 plus 1 it will be equal to 5. That now moving on to this one, right? It's left. Try to calculate left smaller for this one, right? So now, as you can see, this can be extended to the rightmost, like 0 part, right? So we just need to put 0 over there. So now how we are putting 0 over there? This is the tricky part, right? So now 1 is smaller than that of the 3, smaller than that of the 2 as well, right? So we need to pop both of these elements right from the stack. So again, when we find out like 1 is not less than 1, right? This is not the condition. So now our stack is empty. So whenever our stack is empty, initially we, as we can see, like we just need to push 0 into our left smaller array, right? That's why we have 0. And moreover, you can, as you can see, like from the figure over there, its boundary is this. Like its boundary will be this. Its left smaller is between these lines. That's why its length will be 6, right? That's why we put 0 over there. I hope this, like how we are calculating left smaller is clear to all of you guys, right? Now let's move to right smaller. Now let's try to calculate right smaller for this same array. Again, we'll take a stack. Moreover, like we'll use the same stack as we use above. Like we'll, after calculating the left smaller, we'll directly pop all the elements from the stack so that we can reuse the same stack over there, right? So now we'll have right smaller, same size. Over there, we'll have 1, 1, 2, 3, 4, 5, 6, 7, 0, 5, 6, right? So now we'll be calculating right smaller. So we'll start from the right side of the array. So now our pointer will be pointing to 1 initially. So we just need to calculate the right smaller part for this, right? So for this one, like whenever our stack is empty, we just need to push the index, which is 6. Its boundary will be this now, right? This, that's why we need to put 6 over there, right? So in our stack, we'll have 6 and 1. And again, I'm saying like our stack will remain in increasing order, linearly increasing, right? So now our pointer will be pointing to 3. So now 3 is greater than that of the 1. That's why we can push 3 into the stack. So its index will be 5, right? 5 this time. Like now the index will be 6 minus 1, like st dot top minus 1. That's why we write 5 over there, right? So now moving on to 2. So now 2 is smaller than that of the 3. That's why we need to pop this element from the stack. So now we can push 2, 2's index, which is 4, over there in our stack, right? So now what we need to, like 6 minus 1, which will be equal to 5. Remember guys, like this 2 can be extended to, like this 2 can be extended till this. That's why its boundary is 5 out, right? That's why we write 5 over there, like st dot tops index minus 1. In the left smaller, what we need to, we just need to plus 1, right? Like, right? So now moving on to 6. This 6 can't be extended towards right. So its index will be 3. Over there, we have 6 and its index will be 3. St dot top is 4. 4 minus 1 will be equal to 3, right? So now moving on to 5. Our pointer will pointing to 5, right? So we just need to pop this element because 5 is smaller than that of the 6, so we can't, right? We'll directly pop. Its index will be 2 and its value will be 5, right? So now its index will be equal to 4 minus 1 will be equal to 3, right? Because like see now this 5 can be extended to this, right? This will be its boundary, like this will be is its right small boundary. So now we'll have 3 st dot tops index minus 1. St dot tops is index is 4. 4 minus 1 will be equal to 3. That's why we put 3 over there, right? So now moving on to 1. So 1 can be extended towards the end of that. So over there we just need to put 6, right? Why we need to put 6? Again, once again I'm saying our so like since all of these elements are, we just need to pop all of these elements from the stack, right? Right. And we just need to, whenever our stack is empty, what we need to do? We just need to push the right side, which is n minus 1 over there. If we consider n to be the size of the heights, right? That's why we need to push 6, and that we have 1, 1, right? So now moving on to 2, we can directly put 2 over there. Sorry, its index over there, which will be 2, right? Its index over there, which will be equal to 0. Now, directly, now 1 minus 1, st dot tops index, top is 1. 1 minus 1 will be equal to 0. That's why we put 0 over there, right? So now our right smaller and left smaller is also ready for the array. So now what we need to do, we just need to find the area. So how we are finding the area? We just need to use this formula, which is right smaller minus left smaller plus 1 into heights of I. We'll directly use this formula to calculate the area, right? Because we just, for with the help of this, what we calculating, we are calculating the width. So now from this, as you can see, like just take this, the case, which is like this one, 5 and 6. Just take this case, like which is at the 2th index. This, its value is 3 and its value is 2 over there, right? 3 minus 2 plus 1, this will be equal to, and this will be the height. So 2 into 5, so ultimately our answer will be 10. This one is the maximum, the largest rectangle of the histogram, which you can achieve from the given array, right? I hope this approach is clear to all of you guys. Please do a dry run by yourself with the help of pen and paper. Otherwise, it will be a difficult for you guys. Right? Just once again, I'm saying just do a dry run. This will be super easy for you, and how you can think like why we are using stack, right? This, like I can say, like this question can be solved with the without using stack, but this will be a tedious task to do so. So now let's try to got this thing up so that this thing will be clear to all of you guys, right? So here we are. Initially, we'll just take the size of the heights, right? Declare a stack over there and declare two arrays. One is right small and the second one is left small, right? So now we'll just run the loop to calculate the left small initially. Left small while less than n I plus plus. So in this, what we need to do, first of all, we just need to check this condition. Is t, and then heights of st.top, right? st.top, this should be greater than equal to heights of I, right? If this condition holds true, then what we need to, we just need to pop the elements, right? If, let's say, if our stack is empty, so now left small will be equal to left small of I will be equal to 0, right? So you there will have like st.empty, like whenever our stack is empty, then we just need to put 0 over there in the left small. Else left small of I will be equal to, this will be equal to st.top plus 1, right? Plus 1 this time. In case of like left small, in case of right small, we'll just subtract 1 from the st.top, right? st, now we just need to push the index into the stack. So now, as I said, we'll be using the same step. So we just need to clear the stack so that we can use the same stack again. This will save our memory also. We just need to pop from the stack until our stack will be empty. Yeah. So now after this, we need to calculate the right small. So for this, the same thing we need to do. Let me just copy this thing. Yeah. And in this, what we need to do, the same condition will be checked. Instead of left small, what we'll have a right small. And over there, instead of 0, we'll directly store n-1 because we are running our loop from the right side of the array. Again, like over there, we also need to make the changes n-1 then equal to 0 and I minus minus, right? Yeah, this thing will be same as that of the left sum. So now over there, we also need to st.top minus 1 this time because we are then our loop from right side of the array. Otherwise, yeah. After this, we just need to push same. So now, after we calculated like left sum and right small. So now we just need to take the maximum area, right? Calculate the maximum area I equal to 0, I less than n, I plus plus. So for this, max area will be equal to max area, comma. So now the formula will be height of I multiplied by right small of I minus left small of I, sorry, left small of I plus 1, right? Yeah. At the end of this, we just need to return the maximum area. Yeah. So with this, there is one parenthesis missing. So with the help of this, I guess we are good to go. Now let's run this code. Over there is a typo over there. Heights. This will be equal to height. Yeah. Now let's submit this thing. Yeah, this is accepted. So now let's discuss the time and space complexity for the same. Since we are using like one loop for like calculating left small, so this will require big O of n. And while we are clearing the stack, this also will big O of big of n, and the right small will also require big of n, and this loop will also require big of n, right? Big of n, right? And the space complexity will be big of n, since we are using stack over there. So ultimately, you can say the time complexity would be big of n, and the space complexity will also be equal to big of n, right? I hope this approach is clear to all of you guys. Once again, I'm saying please do a dry run by yourself for this question. And now with this video, all the questions of arrays are completed. I'll suggest all of you guys like to solve each and every question again by your own without looking at the solution. Mm, yeah, with this array will be like much easier as compared to like previously when you initially solve all the arrays question, right? Thank you so much for viewing the video till the end. Please do like, share, subscribe, and comment if you have any doubt. Thank you so much.